Okay, 31, a tank with capacity of 400 liters is full of a mixture of water and chlorine with the concentration of 0.22 grams of chlorine per liter. In order to reduce the concentration of chlorine, fresh water is pumped into the tank at a rate of 12 liters per minute. The mixture is kept stirred and is pumped out at the same rate. Let A of T be the amount of chlorine in the tank after T minutes. What is the value of A30? Certainly all the work is written down here for you. I'll think of the whiteboard though and kind of, maybe summarize what I'm saying over here. And what's important about this is you have some idea that what's written is what I'm going to be talking through now. All right, let's put this down, go to the whiteboard. And the first thing is I want to draw a picture of the tank. So I can say it looks sort of like this over here. Right, and what are they doing? They're pumping in water. And as I pump in water, they have a drain here that's pumping out. And there's something in here that's stirring the tank up. All right, the tank is full. All right. So the question is how much is in the tank? Well, there's 400 liters. Again, make sure you have the problem in front of you so you can read it. There's 400 liters in a tank. And at time equals 0, the amount of chlorine, sorry about that, the amount of chlorine in the tank is, they said what it is. Let me just go back and have to read that again. So I know the initial concentration of chlorine in the tank is, well, let's take a look at this. I think they said, let me read that again. Yeah, 22 grams of chlorine per liter. So there's 400 liters, and then there's 22 grams in every liter. And this is of chlorine. All right? So how much chlorine do you have? Let's put this down. A0, the amount of chlorine we have, we just multiply that together. That's 88, right? Yeah, 88. 88 what? 88 grams of chlorine. All right, what's their question now? Well, their question is how much chlorine do you have at 30? That's their question. I don't know. Certainly less than 88, that's a given. Why is that? They're pumping fresh water in. And they're pumping fresh water in at a certain rate. So the rate of the water coming in, this is fresh water. They're pumping in at a rate of 12 liters every minute. Oh, by the way, this is at 30 minutes. And the question over here is how much chlorine is there in grams, by the way. All right? They're also pumping out a rate of 12 liters a minute. Oops. They're pumping out at a rate of 12 liters per minute. Keep it a constant volume. So what do I know? I know the amount of chlorine in the tank at time t is related to, well, what's being pumped in. So it's 12 liters a minute. And what they're pumping in is 0 grams. What are they being pumped out? 12 liters per minute. And then it's uniformly mixed, by the way. It's like really mixing it very efficiently. And what's that going to be? Well, how much chlorine is there? It's going to be A at time t, this is the amount of chlorine at time t, divided by, let's see, 400 liters. All right? And A is at time t. All right, that's how much chlorine's at the time t. Now looking at it, it really doesn't look that bad. I'm going to maybe get rid of the units on it to make it a little bit easier for me to deal with. So dA dt, well, this first term is 0. And then I get 12 divided by 400. Right, so 12 divided by 400. That's negative. I'm not going to put the units down, though. And that's going to be what? 12 divided by 4. Let's see if we can do that. So I'm going to say divide by 4, you get 3 100ths, which is 0.03. So it's 0.03, and that's going to be grams per minute. But let's not put that down, all right? But there is going to be an A there. And A, again, I want to point out, this is going to be a function of time. All right. What do you do here? Well, I gotta, it's a differential question. I need to solve it. Separation of variables at this point. So I give it dA, and I can write down 1 over 0.03 equals, let's see, you know what? I want to do that because I got to get the A. I'm sorry about that. I want to get the A on that side, not that 0.03. Let me put this on again. So I'm going to say 1 over A dA is going to be minus 0.03 dt. Then I'm going to integrate both sides. And I'm actually going to put limits of integration on this one over here. And what I'm going to say is that this bottom limit is going to be A naught, which is how much there at time 0. And this is going to be T naught, and that's going to be what's there at time equals 0. We'll fill it in later. And then this up here is going to be A at T, and over here you're going to have the T. All right? I think I can integrate, and what do you get? You get the natural log, and A is a positive number, so I'm just going to put down AT over A naught, and this is going to be minus 0.03 T. You know what? I should put down, I can't use the T there, I'll put TT down. All right? So TT minus T naught. All right? So I think I got that solved. And let me just put this over here. And so I'll put down the natural log. Let me put this over here. Natural log. I'm going to write now that this AT is actually A is a function of time. A naught was what? Let's go back up here. Oh, 88. And that equals, let's see, minus 0.03. I'm going to go back to using T again. So I'm going to say sometime T minus T naught, which is 0. That's a time 0. So I'm getting close. I'm going to say A is a function of T over 88 is equal to E to the minus 0.03 T. And then AT is equal to 88 E to the minus 0.03 T. All right, so the question is now, do you remember the question? And I kind of remember it. It says, what's the amount of chlorine? This is A when T is equal to, let's go back over here. Yeah, 30, at 30 minutes. What do? It's 88 E to the minus 0.03 times 30. If you do this on a calculator, actually, I guess I could do that multiplication, right? So let's write that down. So 30, and that's going to be times 3 100ths, which is going to be 90 over 100, which is 0.9. So maybe I should do that. Might make it easier to plug into a calculator. This is going to be 88 E to the minus 0.9. Okay, what do I have to do now? I got to take, I got to use a calculator. So using a calculator, I'm going to say, if you use a calculator and you compute this number over here, you should get 35.778, yada, yada, yada. What does it mean, grams? All right, again, let's go back and see what happened. There were 88 grams. They're diluting it. 30 minutes later, pumping all the fresh water in, mixing it well, and draining at the same time. They'd have this number of grams in that pool of water, the mixture. Thank you.